My mission today is I was invited by Professor Levy to give my experience as one of the founders of the power electronics group at Caltech and one of the first two universities in the United States which decided at that time quite bravely to get into this field, both in terms of academic research and academics, teaching and research. That was in 1970 by Professor Middlebrook. I joined in 1974. And at that time, when I joined Caltech, research faculty was electrical engineering and applied physics were one department together, and I think there were about 11 professors. So Professor Middlebrook was one of them, and he just changed his field of expertise from initially semiconductor devices, transistor theory, and moved from device theory into this new field of power electronics. And I was, after I finished my PhD in 2 years at Caltech in 1976, I joined the faculty. So it was quite a big commitment of 2 professors out of 11 in 2 departments in this field. Well, power electronics did exist, so I moved this pointer, just press next one. Okay. So power electronics exists before, and what I would like to do is my theme and goal, just give you overall goal, is how did we start at Caltech? Why suddenly, something which wasn't considered attractive for university to academic research and teaching became attractive, why we were successful, and somehow why Caltech stopped that program with Professor Middlebrook retiring in 1998 and I leaving in 1999, and there was a void. And now question is there any rule? I think there is, and I will hopefully make a good point that there is a need for basic research center, academic research and teaching in power electronics to replace the void left by Caltech not continuing that. And I think, despite the fact that I have maybe half a dozen of my students out of 36 PhD students are professors in the United States and worldwide, and have strong programs in it, but still, I think power electronics needs some very fundamental basic research to be conducted at universities, and that's the point I want to make. Somehow, research at Caltech started in 1970, and the very first conference in the power electronics field was called the Power Conditioning Specialist Conference, and it's 1970-71. And well, that sounded pretty much like air conditioning, and looks like it's pretty low tech, So pretty quickly they decided in 1972 to change it to power processing and electronics conferences. Why? Because aerospace and electronic systems wanted to have, and most of the papers in that field were actually published in aerospace and electronic systems. And then later industry applications joined, and some other control system joined, so all of this then formed this field. In 1973, just 2 years later, it was officially changed finally to the name that it stuck for quite many years, Power Electronics Specialist, okay? And in 1970, September 2010 was a celebration of 100 years of electrical engineering at Caltech. 1910 to 1956, electrical engineering was the power, and was high voltage, laboratory of Professor Sorensen. And when he retired in 1956, as usual, when prime investor goes, retires, the lab is closed. So from 1956 till 1970, there was no power research at Caltech, and was communications and all other things, but not power. In 1970, Professor Middlebrook started this research. I joined a few years later, and in 1999, I left, and Professor Middlebrook in 1998, and that was the end of it. We started at Caltech in both academic courses and research on a PhD level. Second conference in this field was the Jet Propulsion Laboratory in 1971. PESC, in the new name, was in 73 at Caltech, where Professor Middlebrook was chairman of the conference. 1998, to tell you the growth of our group, we had 36 PhD students graduated over this period. In 1998, 11 of those PhD students, because Middlebrook retired that year, were my students in power electronics. So almost like 50% were power electronics PhD students. We started having first sponsors in 1970, actually 72 and 74. by NASA subcontract. In fact, that was paying my tuition and assistantship at Caltech in 1974 when I joined. One of the first companies, one of the first government organizations which recognized the importance and need for that research was Naval Ocean Systems Center in San Diego. And initially they found some 6.1 basic research fund or 6.2, whatever the designations are, and they were able to divert some money to us. And then Office of Naval Research was also an early sponsor. Once we started getting the good results, then IBM joined and many other outside companies and TRW and others. So, how did I get into this field? Like most people in 1970, I got it by accident, because I was in I got my electrical engineering degree with a specialization in nuclear engineering, if you believe, in Belgrade University in Yugoslavia. Then there were not too many reactors then in Yugoslavia, so when I came to the United States, I went to Santa Clara and on a NASA contract, which was given to this professor from Yugoslavia, and I did research on NASA on control systems. And my master thesis was stability investigation of the spinning Skylab. Then after that, Skylab went down, but that's my fault because went out of, after a while it was supposed to burn in orbit. Anyway, in 1973, I received this paper from Professor Millbrook when I applied to many schools. I almost went to Georgia Tech to do a control system with Professor Kaminsky, and he was doing work with Kalman at Florida at the time. And I already signed up for it and accepted the fancy scholarship and so on. And then when I got this paper from Millbrook just in the beginning of March, right before I had to decide, I looked at the paper and I was stunned. He said, here's a circuit, there's one inductor, one capacitor, one resistor, and one diode, and I didn't know how it works. So I said, this got to be very interesting, and it's processing the power. And that's where we are different from signal processing and anything else, circuit, electronics, chips, etc. You can make a function any way you want, from input to output, as long as, proof is compact, did the same, chip as IBM did for their processor and so on. They re-engineered it. And you can do it many different ways. But in power, there is usually one and only one the best way. And that is one which uses smallest number of devices and usually components. And usually these components have to have 3 or 4 objectives to do in that design. Because as you process the power, each component is lossy. And therefore, an objective is efficiency and eliminate all the losses and still achieve the function you need. So when I saw this, it really attracted me and said, maybe I should go into that field. I actually turned down what I already accepted. It was very hard, when you accept something and went to the university president, and now you have to send the 3 letters to all the 3 different levels of turning it down. So